In part 2 of our ideal gas law series, we ended off answering question number 1. Now we're moving on to question number 2 and 3. Question number 2 reads, what volume does 0.556 mole of gas occupy at a pressure of 715 millimeters of mercury at 58 Celsius? Let's go ahead and write everything down. We've been told the number of moles, which I'll represent as the letter N. That's 0.556 moles. And I've also been told the pressure unit, which is 715 millimeters of mercury. That needs to be switched to atmosphere. So let's write that down tentatively. We have pressure is equal to 715 mmHg, and this needs to be converted into ATM. ATM. We'll do that later. Also, we've been told the temperature. The temperature is 32 Celsius. This needs to be converted into Kelvin in order to use the formula that we used earlier, PV is equal to nRT. I'm going to write that down. PV is equal to nRT. The letter R represents the gas constant, and we know what that is. It's right here. Now what we're looking for is the volume. We're looking for V. To isolate for V, we need to divide both sides by P. Watch. This cancels out. We have V is equal to N times R times T divided by P. Before we can insert these values that we wrote in red here into this formula, we need to do these conversions. So let's go from 715 mmHg to ATM. For that, I'll use this table of common conversions. And notice that 1 ATM is equal to 760 torr, where 1 torr is equal to 1 mmHg. So I'm going to take 715 mmHg and multiply it by 1 atmosphere over 760 torr, or if you want, write down mmHg. Notice that this unit and this unit will cancel out harmoniously. Let's go ahead and figure this out. 715 divided by 760, this gives us 0.9407 atmosphere. This number is an exact number, so we don't take into account its number of significant figures. And right now, you don't want to round this number. You want to keep it the way it is, but keep in mind that this is the last significant figure. Everything after that 0 is insignificant. This represents my new P value. Now I have to change 32 Celsius into Kelvin. That's not hard to do. We will be using this conversion, where all I do is take my value that's in Celsius and add 273.15 to it. So our new temperature in Kelvin is 273.15 plus 32. Our answer, using our calculator, 273.15 plus 32 gives us 305.15. And remember, this number should not have any numbers after the decimal, because when you add the significant figures, only count after the decimal place. And since this is an exact, we don't care about the two numbers here. We only care about the fact that there's none after the 32. So I'll put a dot underneath the 5. So we have volume is equal to the number of moles, which is 0.556, times R, and that can be found right here. It's this number divided by, and this is also being multiplied to our temperature of 305.15. Our pressure is 0.9407. Let's go ahead and multiply these numbers out, then divide. I'm going to start with the top. 0.556 times 0.082057 times 305.15 divided by 0.9407, and this gives us a volume of 14.79. The number we just found has 4 significant figures, although we should have only 3. This number had 3 originally, so that being said, this 9, given that it's greater than 5, will push this 7 up, giving us a volume of 14.8 liters. Now, if you would like to see the answer to question number 3, make sure to watch question 3 in this series, and we'll hope to see you soon.